Okay, folks, here we go. If you would please, go ahead and read that first one to yourself. I think you should be able to select your answer there just fine. The first one on the left. That's the answer. So, what's the answer? B as in boy. $12 for jeans and $8 for t-shirts. Yep, should be B as in boy. Does anybody have any issues with that? No? Okay, let's take a look at the next one. I think you should be able to handle this one as well. Go ahead. This one was B as in boy. What do you think about the next one? Yeah, so this is what Derek is doing on his paper. I can tell what he's got going on there. And you're going to add them, right? Because it told you right here, you're supposed to add them. All right, go for it. You can add those together. Find your like terms. What did we get? H, as in Henry, horse. How you doing? Fair enough. Everybody's okay here? Yes? All right. Today, we are multiplying, and more multiplying. It is, actually. Yes and no. Remember with adding and subtracting, you had to match them to put them together, right? We don't have to do any of that with multiplying. I need you to recall, if I give you something that looks like this, what do? You don't distribute. You multiply the coefficient, so this is going to be a -8. Is everybody okay with that? And then what else? So this will be a to the 5th and b to the... That's multiplication, isn't it? Mm-hmm. Didn't I just tell you today we were multiplying, and more multiplying? So today we're going to be doing this, and more of this. We are going to be... What's that? Oh, so fast, yes. As long as you guys can keep up, I'm good. We are going to be multiplying coefficients, and we are going to be adding exponents. And I'm pretty sure Dylan already told me what I'm going to be using here. The distributive property. Now, before we kind of dive in head first on this, I want to use some terminology with you, please. Okay, so please don't just start distributing down there, okay? I need you to stay with me, okay? I want to use some terminology here. Does everybody see this term in the front? How many terms is that? Uno, mono, correct? This is a monomial. What would you call these terms in the parentheses? Those are tri, but this one's a bi though, right? So these would be polynomials. So what we're doing in this first section, I know you said that, but I want to make sure he was good. Okay. What we're doing in this first section is we're taking a monomial times a polynomial. Fair enough? And we're going to distribute. So here we go. Let's just go around the room. Okay. I need you to remember we're multiplying coefficients. We're adding exponents. Good? I'm going to start here. Derek, x times x. Does that have any coefficients that need multiplied? No, but this x has a 1 and that x has a 1. So x times x is... No, not 2x. X to the second power is okay. Everybody okay with that x to the second power? You see how I added those ones, right? Okay, Derek, how about x times 3? Got it. Can those two things be added together? They are not the same. They cannot be combined. We're done. Luke, let's distribute this guy. I need to know what -2 times 4 is. And then I need you to tell me how many x's that would be. Awesome. How's everybody doing with the first term? Good. All right, Luke, how about the middle term now? What's negative 2 times negative 3? Good. And then how many x's will you get there? Everybody good with that x squared? Do you see how we're adding the exponents? Yes? Okay, Luke, how about the last term? Negative 2 times 5. How about negative 10? And then how many x's will you get there? Just one x on that. How are we doing with that distributing? So, everybody see how fast this is going to go, right? It is easy. I'm not a dude, but it is easy. Savannah, the only way I can make this harder is to have more variables, which you have here, x's and y's. Okay, so first of all, multiply. What do you get? How many x's will you get there, Savannah? How many y's will you get there? Okay, how about the middle, ma'am? Yep, how many x's will you have there? How many y's will you have there? Awesome. And finally, on the end, ma'am, how many x's and how many y's? How's everybody doing there? Can anything go together? Are anything matching that can go together? No, none of them variables match. This is x to the third y squared. This is x squared y to the third. They do not match. Right here, this 5. So 5 times 1 is 5. Is that okay? Yep. Okay, I'm up to Dylan for number 4. Distribute the y. What is y times y squared? No. So y to the third. All right, Dylan, how about y times 3y? Good. And how about y times negative 2? Can any of those go together? No. How's my first line? Everybody's good? Are we sure? We're just going to keep moving here. Cody, I'm over to you. Distribute. What is negative 3 times 2? And then how many b's will that have? Yep. How about negative 3 times 4? And then how many b's will that have? Yep. And then negative 3 times that negative 1. And then how many b's will that have? Yep. Can any of those go together? Nope, not at all. None of them go together. All right, Logan, how about 4 times this 5? Okay. How many x's will that have? So we got 2 here and 2 here makes how many? There we go. How about 4 times negative 2? Got it? How many x's will that have? Now that guy has 1 and I distribute the 2, so that makes 3. And then how many y's? So here's my y. Does this one have a y? No, so it's just going to be 1 y in there. Okay. And then 4, it'll be times a 1 on the end there. What does that give you? 4 times 1 is 4. And then how many x's will I have here? X squared. And how many y's will I have here? Y squared. How's everybody doing? Guys, do any of those go together? Do any of them match? No. Okay, Dalton, over to you. Don't be scared off by those fractions. What's that? What don't you know how to do? So you got to tell me what part. That's fine. I just want to know so I can help you. The exponents or the coefficients? So, okay, Dalton, let's look at this for a second. Let's just do kind of a random one here. Okay, please stop. Thank you. Oh, I don't know. Just kind of making it up as I go here. Let's look at this. Okay. So these numbers are coefficients, correct? So multiply. What do you get up there? Yep. Somebody help me out. What's 1/3 times 6? 2. So how many x's will you get here, Dalton? 4. And then how many y's? Yep. Multiply 1/3 times -9. Somebody help me out. 3, and it'll be negative. Dalton, how many x's will you get? And then how many y's will you get? Awesome. And then 1/3 times -3? 1. How many x's will you get? This is Dalton's problem, please. How many y's will you get, Dalton? 3. Is that all right then? Good. Mr. Stahl, take a look at the next problem. How many times are you going to have to distribute? 4 times. You everybody see how I have to distribute twice in the front? Twice in the back? Okay, here we go, sir. What is 2x times x? Okay, what's 2x times -3? And that will have a x on it. How about x times 5? And how about x times -x? Ooh. X times -x. Correct. Now, do any of those go together? Yes. How many x squareds do you get? Yep. How about your x's in the middle? Got it. How is everybody with that final answer? Do you see how we actually could put stuff together there? Yes? Okay, back to the beginning. Derek, distribute, please. Okay. Good. Yep. Uh-huh. How's everybody doing following him? Okay, can anything go together? How many r to the thirds do you get? None. They're gone. How many r squareds do you get? 9. 9 r squareds. How we doing here? Just fine? Yeah? Okay, now take a look at number 10. It's got brackets and parentheses, doesn't it? Where do I start? Inside with the parentheses. So this 3, Luke, this is your problem. That 3 has got to come first, okay? So I'm going to rewrite the A bracket 2A. Now I need you to distribute that -3. Got it. Does everybody see why that's a positive 3A? Okay, Luke, now that those parentheses are gone, now you can distribute the A. So what do we get here? 2A to the... You see how that would have a 1 and that would have a 1? Okay. How about the middle part there? A times -3. And then how about A times 3A? Got it. 3A to the second. Now, Luke, do any of those go together? This one and this one? Gives me how many? Oh. 5A to the... 5A to the second. Is that okay? We're not going to add those exponents. The only time we do that is when we're multiplying things. Here, we're not multiplying. We're just putting them together, okay? Is everybody all right with that? I'm actually kind of glad you said that, Luke, because a lot of people make that mistake. Is everybody good with keeping this a squared instead of a to the fourth? Yes? I should have 2 problems down at the bottom, do I? Great. Do them on your own. Multiply the coefficients, add the exponents. None of this stuff should go together. Just distributing. Bless you. How'd we do on that first one? We got it right? Yeah, exponents are all good, coefficients are all good. Okay, now P's and Q's can kind of get confusing because obviously they look very similar. Okay, hopefully you have 6p to the third q to the third minus 3p squared q to the third plus 15p q to the fourth. How'd you do? Got them all? Good. Just one little guy? Okay. Everybody's all right? Great. Well, if you can do this, then the back is basically just doing this more. Okay? Now, instead of a monomial times a polynomial, it's going to be a polynomial times a polynomial. Tell me the rules. What do you do with the coefficients? Multiply coefficients. What's the other part of the rule? Add exponents. So now I'm going to multiply a polynomial by a polynomial. If you look at all these, actually, what are all of these? They're not really polynomial times a polynomial. They are binomial times a, look at them. That's all binomial times binomial, isn't it? 2 times 2? Fair enough. In order to do this, we are going to do repeated distributing, which is why I said, basically, if you can do the front, we're just doing more of this on the back. It's repeated distributing. And don't worry, we're not doing all of these problems. Whatever I don't get done, I might give you for extra credit. We'll see how it goes. Okay? Yes, no? Okay, so here's what's going to happen. You see this binomial times a binomial, yes? You are going to split the first binomial in half. Please notice that I did it right after that first term. So I'm going to take the 2x, that's the first half of it, right? And I'm going to distribute it to the second parentheses. See it? Hold on, I'm not done yet. Then I'm going to take the second half, which is plus 5, and I'm also going to distribute it to the second parentheses. This is why we call it repeated distributing, because I cut the first one in half, and I distribute both pieces to the second parentheses. How is this for everybody? You sure? Good, let's do it then. What is 2x times x? What is 2x times negative 2? X, right? How about 5 times x? And 5 times negative 2. All right. Now, does anything go together? Now, I'm going to keep the 2x squared first. Okay? And then what is negative 4x plus 5? Just an x, and then minus 10. So that would be your answer. Okay, so that's what we're looking at for the back of this page. Hence why I left you a little bit more room in between all of these, right? Yes. So here we go. Luke, I think I left off with you. So Savannah, cut the first one in half. Can you tell me the first part we'd be distributing? Okay, what's the second part then? How is everybody with the setup? Okay, distribute now, Savannah. Keep going. Okay, looks like the middle goes together again, ma'am. What do I get? Got it. How we doing? Good? All right, Dylan, you're next. Let's cut this first one in half. Can you tell me the first part of this? No, like the setup first, and then we'll go to that. Times, minus, or plus. Okay, then what? No, what's the second half of this parentheses? Minus 2? You see that minus 2? And then distributing that times what? Okay, so now tell me what you get when you distribute, sir. Keep going. Yep. Good, and it looks like the middle goes together again. What do you get in the middle? Got it. Everybody doing all right? All right, Mr. Stahl. You hop seats on me. You're next. What's the setup going to be? Okay, and then the second part? Times? Good. Go ahead and distribute. Okay. Uh-huh. Close. Negative 9a. And then minus 3, right? Okay, last but not least, put your a's together in the middle, and what do you get? It is, yes. Got it. You guys are doing great. You feel like you're doing great? Because you are. Yeah. All right, Cody, we ready to go on to the next row? Yes? All right, cut it in half for me. Can you tell me what the first portion of this would be? Okay. What's the second part going to be? Plus 7 times. Good. Does everybody see how the symbol in between them always goes with the second part? Yes? Okay, distribute, Cody. What do we get here? D times 2D. 2D to the second. Okay, D times negative 4. Good. How about 7 times 2D? Good. And how about 7 times negative 4? Perfect. Put your middle two terms together, Cody. And what do you get? Perfect. Love it. Love all of it. It's all good. It's all good. Good. I want it to be easy. All right, Logan number 5. We're going to cut the first one in half. And can you tell me what the first portion of that would be? Perfect. Awesome. So what is a times a? A to the second power. What's a times negative 2? You're stumped, so there would be a 1 in front of here, right? No. There's a 1 in front of here, yes? What is 1 times negative 2? I can't hear you, kiddo, with these things. Negative 2, and then we got to put an a on it, okay? Now, what is 2 times a? 2a, because there's an a right there, right? And then 2 times negative 2. Negative 4. Good. Guys, you see how the middles keep going together, don't they? Logan, what do you get here in the middle? Negative 2a plus 2a. What's negative 2 plus 2? Be 0. So, folks, I don't have anything in the middle. Can somebody tell me what in the original problem made that happen? Folks, look at the original problem. Yeah, do you see how they're the exact same things, just one is a plus and one is a minus? That's what made the middle part cancel out. You should like those problems. They are very, very easy. All right, doll number 6. Let's cut it in half. Okay. Yep. Uh-huh. Wonderful. Uh-huh. 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 Yep. You can barely keep up with you. That's perfect, dude. Perfect, perfect, perfect. I love it. Love it. It's good. That's great. How we doing? No questions, right? Great. We're going to skip the next row. It's going to be extra credit if you want it. And we're going to go to this guy. Uh-huh. Yep. Are you ready? I'm not a boy. Okay. Now, folks, look at this original problem. What do you notice about this original problem? They're the same, right? Except for one's plus and one's minus. Agreed? So remember Logan's problem he just did? They should cancel. They should. Let's see. Derek, I'm over to you. What we got? What's the setup? Okay. Okay. Okay, distribute. Was B times C? BC? Is there 2 B's when they're getting multiplied? No, there's only one of them, right? Okay. Keep going. Perfect. So, does the middle cancel like we said it was going to? It does. So, what's my final answer? Do you guys want to do another one of those that have the 2 different variables? Well, I was just going to swap out one. Like, I'm going to go back and do another one and not do one of these. Okay. So, let's do 7. Let's do 7. Luke, I'm back to you. Can you tell me the setup, sir? Okay, distribute. There you go. Yeah, we're going to put them in alphabetical order. Yep. Not plus. Got it. Now, the middles do not cancel here, Luke, because those problems at the beginning were not the same. Okay. What do you get, though? WY minus 6WY. You got it. Negative 5WY. Fair enough? Okay, we're going to do one more. We'll call it a day. 9? I like 9. Savannah, you ready for 9? Okay, can you tell me the setup if I cut this first one in half? It is an L, and guys, I'm going to make my L cursive so it doesn't look like a 1. Keep going, Savannah. Okay. Can you distribute for me, ma'am? Now I'm going to put them in alphabetical order. I'm going to say JM, okay? And then what? Did you say 4KL, Savannah? Okay. Minus. Got it. Hey folks, do these middle terms go together? They don't, because if you look at the beginning problem, they were all different variables. None of them were the same, were they? So nothing's going to go together. Fair enough? Okay, so you've got 3 questions for extra credit if you choose. Where are you going to put that? On the back of your homework, at the end of your homework, which is that. Got it written down? Write it down first, because I'm going to get rid of the screen probably while you're going to have to wait till he comes back. Guys, we're not starting this every day. I can tell you that. I'll let you go today, but we're not doing this every day.